So here's that monster transformer. So let's see what happens when we power it on. Now, I'm not just going to shove mains directly into it, obviously. So what I've done first is Firstly, I checked is this metal casing earthed, which it is connected to earth. We haven't got an earth connection, but it doesn't matter. Checked if the metal of the transformer is connected to is grounded through to the case, which it is. I'll just scrape that a little bit first, but we've got an earth connection. And now what we've got is I've wired the primary to a piece of wire, to a plug, but through this 40-watt light bulb. So basically what's going to happen is the transformer should not be a short circuit. Now, the primary did read quite low, it read about 6 ohms, but that's still not really a short circuit, and that's only the resistive effect of the transformer primary. The inductive effect of the winding is also what limits the current. So but basically the transformer primary is wired so that it has to pass through the light bulb. Now if the transformer starts drawing any serious amount of current, the light bulb will start to light and it will dissipate the power instead of the transformer. So this is basically a good safe way of powering up anything mains powered if you don't know if it's going to go bang or not. This is also a good trick to use with any sort of switch mode power supply. If you put it under load, then the bulb will light because there is current being drawn, but as a safety startup test, this is ideal. Unfortunately, that has to be a good old-fashioned incandescent light bulb with a filament, because it's actually the filament that's the important thing. Basically, the filament acts like a big power resistor that's got a positive temperature coefficient. And so basically, as the power goes through the circuit, the bulb filament gets hotter, and it actually increases in resistance when it does that. So it's kind of like a current limiter. Anyway, so the big moment, switch on. And that's good, the bulb hasn't done anything. So let's get the meter, and this is going to be interesting doing this while holding the phone camera. Yep, as you see, made a mess of that. So let's stick our probes on one of those terminal blocks there. Just shove her in there, and we get, as I thought, about 12 volts, 12.4 volts. So yeah, literally this has been used as some sort of lighting transformer. I'm betting they're all the same. Let's try another one. Yeah, about the same, 12.4. The third one, 12.4. Yeah, they're all the same. So basically that's what this transformer's been used for. It's been used to run a load of 12-volt lighting. So, and the interesting thing will be is that we can get the laminations apart, and they are actually a bit they're a bit wonky actually. You see there's a big lump in the middle, and if you look down there you can see it's uneven, and you can actually see they missed one of the eyes in between the E's there. So, but it's obviously worked well enough. Now the thing to work out will be, if you know this core width here, what you need to know is the size of the tongue that's going through the middle of the transformer, and if you know that, by square area you can work out the volt amp capacity of the transformer, and you can unwind all those 12-volt secondary windings and make a power supply out of it and wind on a custom primary winding. Well, technically you could do it without rewinding. You could arrange those 12-volt taps in in series. You could arrange those to the 12 volt taps in series and then select with relays. I might do that and see what happens. Anyway, there we go. I didn't go bang, I didn't die, and it does still work.